Our code are getting a bit more complicated, so I want to take this opportunity to explain, for example, this team class. It uses a whole set of things that we have learned so far, and with different, with pretty like 3 layers of nesting. So I want to explain this. Um, so what we define here, we say that team is our class, so the system knows team is a class. And then we want to define this team. We want to give the computer more information about this team. The more information we give to the computer, we give computer more opportunities to infer new knowledge. Um, so if you have ontology without any equivalent class or restriction class definition, you basically just have a thesaurus. Okay, so we define this team to have an equivalent class, and this equivalent class start from this left square bracket to this end square bracket. So that the whole thing here, inside here, is a definition for this equivalent class. It's an unnamed class, but basically by saying this team is equivalent to this, we provide the definition for team class. Okay, so how do we define this unnamed class? Again, we say it's a class. If we don't say it's a class, because the open world assumption, I wouldn't know whether you're doing a class or instance or property or something else. So it can't really do anything. It will reason everything is nothing because it does not understand what you think, what you're talking about. So therefore, it's important to say it's a class. And this class is basically the intersection of 2 classes. So starting from this round left brackets to this round end bracket, we define the intersection. So the intersection contains 2 restriction class, again 2 unnamed class. The first class is saying that, okay, anything in my class, in this class, any individuals in my class needs to have minimum 10 players for their highest player property. We're not saying it's a team. We say anything that with 10, minimum 10 players are members of this class. And the second one is similarly defined as it's saying anything with maximum 12 players falling into this class. And we're doing intersection. So if you imagine that we're drawing the Venn diagram, the left circle will cover all the members from this class, has minimum 10 players. The right circle going to cover the second restriction class, has maximum 12 players. You can imagine that in between, in the intersection of these 2 circles, going to be the anything that has between 10 and 12 players, right? So those are the members falling into our team class, because what we're saying our team class is holds the member that belongs to both of these 2 named classes. Okay, so this is how we used equivalent class, intersection of, and restriction anonymous class to define a class. I want to note that we used minimum qualified cardinality. The concept of this is very similar to minimum cardinality. It's qualified because we qualified it on the class. We say you must have 10 players, not 10 things. We restricted on the cardinality, so you have 10 players. So minimum qualified cardinality have to used with on class to fully define this how many instances from certain class you need to have. Okay, this concludes the explanation and demonstration.